Hi, I want to make a full bridge rectifier. That's right, it's not a dumb single diode rectifier, it's a full bridge. What is a rectifier? It basically converts AC alternating current into DC direct current. Full bridge is basically made of 4 diodes in this arrangement. The rectification can also be done with a single diode. What's a diode? It's like an electrical check valve that allows current in one direction but blocks it from going back. If you provide an AC voltage to a single diode, it outputs the positive half of the wave. If you put a capacitor at its output, it holds the voltage close to the peak of the wave as DC. Now a full bridge rectifier converts both the positive and negative peaks into positive bumps at the output. Adding a capacitor at the output converts it into DC again. Generally, a single diode is used for low power rectification as well as DC reverse polarity protection. But a full bridge rectifier is used for high power rectification as well as reverse polarity protection. Now here's my design. When connected to 120 volt AC line, it is designed to output close to 170 volt DC at no load and capable of driving 10 amp maximum load. So naturally there is a 10 amp fuse at the input for protection, then the diode bridge. The added inductor helps with ripple filtering. Here's what I've made. It is pretty huge, which of course can output over 1000 watts, unlike your puny wall adapter that can do 20 watts at best. Now let's plug it in. I have some loose wires connected to my circuit which I will stick into the power plug. As you can clearly see, I have no regards for safety. Don't be like that. See, this electricity is not going to jump at you because it doesn't have high enough voltage to jump. The only way you would get hurt is by touching live wire. So insulate your circuit properly, wear safety gloves, and don't touch with your bare hands. Bare hands. Bah! Why do you call them bare hands? I'm going to touch 170 volt DC with my bare hands. There is 166 volt on the output. Now I'll put my finger across the output. See, I can barely feel it. DC is much less dangerous than AC. Barely. What's up with birds in your language? I feel so burly today. Brr. Bridge rectifiers are widely used in AC to DC converters. As far as I know, all your wall adapters contain one of these circuits. Now I will measure some waveforms. I connected the probe to my output lines, connected my circuit to this power bar, and now I will turn the power bar on. My fuse just blew up. Something I realized the hard way is that the ground of the probe is actually shorted to the earth of the power plug through the scope. So what happens is that when I connect the ground to the negative output of the bridge, it shorts the live wire to earth every negative cycle of the AC. And that's why we have fuses, to avoid exciting wires. Now I'm using this tape called Kapton tape to insulate the earth of the power cord. I have the same setup again, and with the probe connected, I turn the power bar on. We are safe now. As you can see on the scope, the output voltage is around 170 volts. Now I like to use my 100 ohm resistor and connect it to the output to see how the waveform changes. A quick calculation shows having 170 volt across 100 ohm generates 300 watts of power. It's like having a 300 watt lamp within your fingers. It burns your skin very quickly. Now I use pliers to hold the resistor. See, the output voltage drops, but with very small ripples because there is a lot of filtering. Wow, I was holding that. I let it cool down for a while and the ceramic core takes a long time to cool down, and now you can see that the resistor is made of resistive wires wound around the ceramic core. Anywho, this power supply will eventually feed my high power Tesla coil driver circuit. Oh, remember, in such circuits, although unplugged, the capacitors hold charge for a long period of time, so always discharge them with some resistor.